Hi everyone. Today I'll be covering a feature of Amazon EMR which is now generally available for using EMR with targeted on-demand capacity reservations, or targeted ODCRs. I'll start by reviewing the problem statement which led to EMR building this feature. I'll review the steps to take in AWS to use targeted ODCRs with EMR. I'll talk about the capacity allocation logic that EMR uses with targeted ODCRs. I'll walk through two example use cases, then I'll do a quick demo to show it in action. Customers use ODCRs for better capacity assurance, especially for workloads with SLAs. By creating capacity reservations, you ensure that you always have access to EC2 capacity when you need it for as long as you need it. You can create capacity reservations at any time without entering into a 1-year or 3-year term commitment, and the capacity is available immediately. Billing starts as soon as the capacity is provisioned and the capacity reservation enters into an active state. When you no longer need it, you can just simply cancel the capacity reservation to stop incurring any charges. ODCRs can be either open or targeted. If the capacity reservation is open, new instances and existing instances which have matching attributes automatically run using the capacity of the capacity reservation. So in an EMR cluster, if it's launched matching the attributes like operating system, instance type, and availability zone within the open ODCR, it uses capacity from that ODCR first. So if the capacity reservation is targeted, instances must specifically target it in order to run with that reserved capacity. So now generally available, Amazon EMR has built support for specifically targeting a targeted ODCR. So why was this built? So until support for targeted ODCRs, EMR could only use open ODCRs, which was done by launching instances matching the attributes that I had mentioned before. So if you have multiple workloads using the same attributes in the same AWS account and region, such as multiple concurrent EMR clusters, they would both use the same open ODCR. So if one cluster required a higher quality of service than the other, say it has a stricter SLA, customers needed to get creative in how you're launching resources within your AWS account. So in order to ensure certain ODCRs are only used by specific EMR workloads, customers asked for a way to specifically specify the targeted ODCR when launching the EMR clusters. And also from a user experience perspective, customers wanted to ensure that if they request more instances than specified in the targeted ODCR, they can fall back to on-demand EC2 instances that are in the same AZ. And because of these customer feature requests, Amazon EMR instance fleets now supports customers specifying targeted ODCRs, along with a flag to use capacity reservations first. Using EMR with targeted ODCR is really a 3-step process. And the first thing you need to do is actually add the required permissions to the EMR service role as a prerequisite. The EMR service role requires the 5 permissions specified on this slide. And EC2 supports scoping access down to a specific capacity reservation ID in the IAM policy statement's resource value. Likewise, the AWS resource groups team supports scoping down to a specific resource group name for the resource value in the IAM policy statement. And step 2 is to create the targeted ODCR, the resource group, and then you associate them in the resource group's grouped resources. And third, you create your EMR cluster with the following configurations. So EMR's allocation strategy feature is available in EMR version 5.12.1 and later. It optimizes the allocation of instance fleet capacity and lets you choose a target strategy for each cluster node. On-demand instances use a lowest price strategy, which launches the lowest priced instance first. And the allocation strategy option also lets you specify up to 15 EC2 instance types per task node when creating your cluster, as opposed to the 5 maximum allowed by the default EMR cluster instance fleet configuration. You also want to specify the service role from step 1, and you want to specify the ARN of the resource group from step 2. And then you'll need to use the use capacity reservation first instance fleet option. So for a more visual review of what we just talked about, first, starting on the right side of this, we have the IAM policy that we're creating and attaching to the EMR service role. Second, on the leftmost side, we create the capacity reservation, the resource group, then do an association between the two. Once associated, the EC2 capacity reservation will be in the group resources. Then when you're creating your EMR cluster, you have to specify your IAM role that you have there, the resource group, and then the use capacity reservation first argument. So I'm now going to cover the capacity allocation logic that EMR uses when working with targeted ODCR, starting with the core nodes because the core node allocation determines the availability zone or AZ for all instances within that EMR cluster. So once the core node capacity is acquired, EMR locks in the AZ for your cluster. In here, I mentioned instance pools, which EMR defines as the instance type AZ combination, which are determined by the instance types in your fleet configuration and the subnet that you specify. When the use capacity reservation first option is chosen alongside the targeted ODCRs when EMR is allocating capacity for core nodes, EMR evaluates all the targeted ODCR instance pools first, ordered by the lowest price. EMR will first try to find the instance types with unused targeted ODCRs that can fulfill the request for all of the core nodes. EMR will then launch the core nodes into those the targeted ODCRs with that single instance type if a targeted ODCR instance pool has the capacity. If none of the instance pools meet the criteria, EMR will fall back to launch the core nodes into the on-demand instance pools sorted by the lowest price instance first, and it will use the targeted ODCR instances if available for that instance type. So that was the logic for the core nodes, and now I'll cover the master and task node provisioning, which also applies to resize operations. Once the core capacity is acquired, EMR locks onto that AZ and attempts to provision the master and task nodes within that locked AZ. Since the AZ has been determined, EMR will be evaluating instance pools within that AZ. So first, EMR will evaluate all of the instance pools with targeted ODCRs specified in that request, ordered by the lowest price first. Then, from the ordered list, EMR will try to launch as much capacity as possible from the unused targeted ODCRs of each instance pool until the request is fulfilled. Lastly, if the unused targeted ODCRs don't fulfill the request yet, EMR will continue to launch the remaining capacity into on-demand instance pools in the lowest priced order. So that was a lot of text. So let's look at a few use cases to better understand this behavior. In this use case, your account has 1,000 unused instances in the targeted ODCR for the R5 extra large instance type in US East 1A, and you have chosen the use capacity reservation first option. You specified 3 instance types in your request. So you have the R5 extra large, C5 extra large, and M5 extra large, which are all specified there. And C and M cost less than R in this example, but C and M don't have targeted ODCRs, and only R does. You requested a capacity of 100 instances for core nodes and 100 instances for task nodes. So what this looks like whenever you're provisioning is EMR will fulfill all the core nodes with R5 extra large, since your account has enough unused targeted ODCR for the R5 extra large. So at the end of this operation, you'll have 900 unused targeted ODCR instances in your account. And it doesn't use any of the C5s or M5s. And since you have more R5 in the ODCR than you requested, it doesn't use any of the on-demand instances. During task fleet provisioning, the AZ is locked to US East 1A. EMR will try to launch as much capacity as possible from the unused targeted ODCRs of each instance pool until the request is fulfilled. So in this case, the task nodes will be provisioned using 100 R5 extra large from the remaining 900 unused R5 extra large in the account. At the end of the operation, you'll have 800 unused targeted ODCRs in your account. And overall, in this use case, the cluster will get provisioned with 100 R5 extra large for core nodes and 100 R5 extra large for task fleets. At the end of the provisioning workflow, you'll have 800 unused targeted ODCR instances for R5 extra large. So that was a very simple example. In the second example use case, your account has 10 unused targeted ODCR instances for each of the 3 instance types in US East 1A. And you've chosen the use capacity reservation first option. You specified 3 instance types in your request, and again, you requested a capacity of 100 units for core and 100 for task nodes. So for the sake of this example, C is the lowest cost, then comes M, then R is the highest cost. During provisioning of the requested capacity for 100 core nodes, EMR will attempt to fulfill all the core nodes with a single instance type from the unused targeted ODCRs. As the unused targeted ODCRs for any instance type is not sufficient, EMR will fall back to provisioning the core nodes with on-demand capacity. So EMR will sort the instance pools based on the lowest price. And since C5 extra large is the lowest price and it has greater than or equal to 100 on-demand nodes available in US East 1A, EMR will fulfill all of the 100 core nodes using C5 extra large. Since 10 of these instances are already reserved in that account, EMR and EC2 will honor that. So the launch count in targeted ODCRs is 10, and the launch count in on-demand is 90. So at the end of the core node provisioning, the account will have targeted ODCRs for 10 unused M5 extra large and 10 unused R5 extra large because the core nodes are all deployed with the same instance type. During task fleet provisioning of the requested capacity of 100 task nodes, the AZ is still locked to US East 1A. Here, EMR will try to launch as much capacity as possible from the unused targeted ODCRs of each instance pool until the request is fulfilled. So in this case, EMR will launch 10 M5 extra large using its unused targeted ODCR, followed by 10 R5 extra large using its unused targeted ODCRs. And then it will fill the remaining part of the task nodes using on-demand instances based on the lowest cost. So since C5 extra large is the lowest price and it has greater than or equal to 80 on-demand instances available in US East 1A, it uses 80 on-demand C5 extra large instances after it uses 10 and 10 from the M5 and the R5. So at the end of the task node provisioning, the account will have 0 unused targeted ODCR capacity for all 3 instance types. And the task fleet will launch with 10 M5 extra large using targeted ODCR, 10 R5 extra large using targeted ODCR, and 80 C5 extra large using on-demand instances. So overall in this use case, the cluster will get provisioned with 100 instances for core fleets using 10 from targeted ODCR and 90 from on-demand for C5 extra large instances, which is depicted on the left side, and 100 instances for task fleets, which has 80 from on-demand for C5 extra large, 10 from targeted ODCR for M5 extra large, and 10 from targeted ODCR for R5 extra large. And at the end of the provisioning workflow, you'll have 0 unused targeted ODCR instances within your account. So with all of that said, I'm going to go over to a demo. To start the demo, first I'll provision a few required resources, and to do that, you can run through the prerequisites however you want, or through whatever means your organization allows. For this example, I'm using AWS Cloud Shell, and that's a browser-based shell which is pre-authenticated using your AWS console credentials, and it has a lot of the common tools pre-installed that you need. I'm just using the AWS command line interface, so to go through a few commands to set up our targeted ODCR. So the first thing we'll want to do is actually create the capacity reservation. So here I'm going to do some copy-paste action and paste it in here. We have a trailing line break, so it'll execute once we hit the paste button. But we're doing an AWS EC2 create capacity reservation. We're specifying one instance type, which is the R5 extra large. Instance count is 5 instances. Instance match criteria is targeted. That's where it could be targeted or open. Instance platform is Linux or Unix, which is the what EMR uses, and then we're specifying a specific availability zone, which is US East 1A. So we'll paste this in there, and we'll actually have to capture this ARN here, because what we're going to want to do is pass this in whenever we're associating the capacity reservation to the resource group. So pasting that back into my text file here. And the next thing we'll want to do is actually create the resource group. So pasting that into here as well. So we're doing an AWS resource groups create group. we're naming it Demo Capacity Reservation Group or CR Group. And we'll paste this in there as well. And we'll get the ARN because we'll actually want to paste this into to our Java code. So pasting that into my text file. And now the next thing we want to do, which is associate the two, and that's with the ARN that I had mentioned that we want to save before the output from our first command. And so I pasted the command itself. I'm getting the resource ID now. And we have a trailing command or trailing line break as well. So resource group resources. We specify the demo CR group here, and then we specify the resource ARN, which is the capacity reservation. We then paste that in, and we can see a list returns, and we see that this capacity reservation succeeded in being associated with the demo CR group. So next, before we go into the Java SDK code for starting up our clusters using the targeted ODCR, I want to show the IAM policy that we had mentioned before. So here we can see the 5 actions that we're required to provide access to. So you can see it needs EC2 permissions to create a launch template version, delete, and describe as well. But the one thing that I do want to call out, and the action resources and conditions key documentation is pretty well done. For the resource group permission that we have to provide, we can actually lock down to the group resource. So if we want to scope down the IAM policy, we can say, all right, we're going to say the specific ARN of the group name that we have and lessen those permissions so that it's least privilege and we don't have a star in the resource. And similarly with the Amazon EC2 permissions that we're providing, we can specify the capacity reservation as well. And so now getting into the code itself, I'm going to minimize this for now. What we actually have here, so we have the importing of the AWS SDK things that we'll need. And I mentioned copying the resource group ARN, but actually when you delete them and create them, they actually have the same ARN, so don't have to replace that here, but specifying that as a variable. We have the region US East 1, and we have the subnet that we're deploying our EMR cluster into. And then after we instantiate the EMR client, that's where the fun begins to happen. So the following 3 methods are kind of what's used to define your EMR cluster and your instance fleet configuration. So mentioned in the PowerPoint, right, we had the use capacity reservations first flag as the usage strategy. And so that's where we specify this. And then we pass the targeted ODCR option into the ODCR specification. And here we can see, we're using the lowest priced allocation strategy like we had talked about. And we're then passing in, that we're using the capacity reservations first and the resource group ARN that we have here. And lastly, we have the launch specifications where we're just simply passing in the ODCR specification, which has everything in the methods above. The next thing that we want to do is have the instance type config for the different fleets that we'll be having here. So here we just specify for the main core and tasks nodes that we're going to have R5 extra large. And then for the master fleet and core fleet and task fleet, we're passing in the launch specifications for each of those and passing in the instance type config for task core and main. And here's actually where we're specifying the number of instances that we're deploying. So in our case, we're just deploying 4 instances. So the core nodes will be deployed first. So there's 2 of those. And then we have 1 of master and 1 of task as well. The next 2 things that we do, we're defining our job configuration. So here we're saying the instance fleets that we defined above. We specify the subnet here, as well as right now we're saying keep job flow alive when no steps, because we're not passing in any steps. This is just purely for the sake of the example of showing how it's using the EC2 instances. And then lastly, we have the definition of the job request. So here we specify name. We're specifying the service role, which is the role where we added the policy that I just showed a minute ago. And then the job flow instances config as well. And lastly, we're actually executing against the API and saying, here's our job flow request, and then outputting that job flow ID. So here I will run the application. So the application ran, and we can see that the EMR cluster is starting. And if we click in to this, we can see that the core nodes, it'll have 2 units, task, it'll have 1, master, it will have 1. And then now, I've run this a few times, so ignore some of the noise here, but if we go to active, we can see 3 of 5 quantity is still available, meaning the task nodes have deployed first, since there were 2 of those. And as time goes on, it'll go down, and eventually we'll have 1 of 5 available in the case of what we're testing. So if we go to AWS Resource Groups console, we can see the demo CR group. And if we click into that, we can see the group resources, which includes the capacity reservation resource, which takes us back to viewing the capacity reservation that's in this tab. Okay, so after a few minutes, we came back into the console. What we can see is that we have master nodes, core nodes, and task nodes. All are successfully running. We have 4 units in total. And so if we go over to capacity reservations, we can see that it's a targeted capacity reservation, and there's 1 of 5 available, meaning we're using 4 out of the 5 within the targeted ODCR. So our EMR job is successfully using the on-demand capacity reservation. And as a result of that, we can say, all right, we need a particular instance type, a large amount for one particular job that's SLA bound. And we can now say that our job is successfully using that ODCR that we've created for it. So I hope this was helpful, but this is how you use targeted ODCR with Amazon EMR. Thank you.